Hello, friends. Another NT podcast, Science and Theology. My name is Nemanja, and Dr. Russell Humphreys is here with us today. He's a nuclear physicist and one of the leading Bible-believing creationists. Dr. Russ, welcome, and how are you?
I am happy to be here, and thank you for the privilege of talking to your audience about things that I really like to talk about. So,
I like to talk about this also, and you're my one of favorite creationists, and this is a real privilege to have you here. And thank you for your time because you're too busy and you work a lot. So, can you just briefly tell us about yourself? What do you do? Because you're nuclear physicist and creationist. Is it possible even?
I'm a retired physicist, and by the way, I'm not a nuclear physicist alone. I've done a lot of different types of geophysics, geophysics and astrophysics, and uh, even geochemistry and some geology, but physics is a good base from which to explore all those different fields of knowledge. But I don't specialize in nuclear physics, but I have done nuclear physics. So anyhow, I retired from a laboratory in the state of New Mexico out in the western United States called Sandia National Laboratories. I worked there 22 years as a physicist on all sorts of projects. Some of them were classified nuclear weapons types of projects, and others were interesting geoscience projects. I've done a lot of different physics, and in my spare time, I have written and spoken and researched a lot of areas of creation science, including this area we're going to talk about tonight on the magnetic field of the Earth and of planets. So,
Yes, thank you. You mentioned that our topic is electromagnetic field of Earth, Sun, Moon, and other planets. So, my first question is, what is the origin of the Earth magnetic field? And does that seem like it is fine-tuned and designed by God?
uh, well, um, it was all designed by God, and you'll see when we get, first the present physical origin. I've got my this is a slide I use from some of my talks, and points out that the Earth's magnetic field is losing energy too fast. Now, the Earth's magnetic field has done complicated things in its intensity, but the overall energy that's stored in it has always decreased, sometimes fast, sometimes slow, and sometimes rather complicated. But it's losing energy too fast, and right now uh, it's losing about half its energy every 1,400 years. Now, to answer your question, uh, let me get past this. By the way, that it couldn't lose energy at that rate very fast because, say 20,000 years or so ago, it would be the electric current that generates it uh, is too high. So why didn't I get back to there? There's the electric current in the Earth's core. It's going westward, and these little uh, circles are contours of the electric current. And, you know, according to the most simple explanation from physics that we have, this current is uh, just running down slowly because the Earth's core has electrical resistance. So you know, as a electrical engineer, that the inductance over the resistance gives you a certain time constant of decaying, of slowing down. And the inductance that you get from the size of the current and the resistance that you get from guessing what's in the Earth's core give you about the right rate that we're seeing, losing half its energy every 1,400 years. So that's the current origin. But you may be asking, how did this current get started? What is the origin of that? and that's a lot more interesting. So I've had a theory. I started it, I published the first pages of it back in 1984 in the Creation Research Society Quarterly. And the theory is basically that it takes what the Bible says the earth was to begin with, which was not the materials it's now made of, but just plain water. There's several verses about that. For example, 2 Peter 5:8 says the earth was formed out of water and by means of water. So I said, well, if God wanted the earth to have a magnetic field, when he was creating the water, he could create it with the protons in the water molecules. You know, water has 2 hydrogen molecules. It has oxygen and 2 hydrogen, and the nuclei are spinning little balls of charge. And we know the magnetic field that those nuclei generate. It's been measured in the lab. And it turns out that if God created that water, original water, with the 2 protons spinning in the same direction throughout the whole ball of water, that the magnetic field would be about 8 Gauss, or I forget what that is in millitesla. But anyhow, it's more than enough magnetic field that if you account for the decay of the Earth's magnetic field in 6,000 years, you get today's field. So the origin is water, but water in a very unnatural state, in its created state with the hydrogen nuclei spinning in the same direction throughout the water. And it wouldn't stay that way, but as various things would happen, the spins would get misaligned, but you'd get a large electric current through the water from just the regular laws of electricity and magnetism. And then when God converted the water, I think miraculously, to other materials like iron and silicon and oxygen and all the materials of which the earth is made, the earth's core would still preserve that magnetic field by having an electric current in it. So, but this theory only works if the original stuff were water and not something else, and if the field originated between 6,000 and 10,000 years ago. So that's miraculous. So that points to design, yes. And it turns out that if God made the planets and the sun and the stars the same way, out of water to begin with, then you get the right magnetic fields for each of those bodies. And so I made some predictions back in 1984 about the strengths of the magnetic fields that the Voyager space probe would uncover when it visited some of the outer planets of the solar system. They hadn't been visited, so they didn't know what the field was. They had their theory. Their theory turned out to be wrong, really wrong in the case of the planet Uranus. And the theory I had, just based on scripture, gave the right answer. So, and there's other parts of the solar system where the theory gave the right answers too. Like for the planet Mercury, several things about the magnetic field of Mercury turned out to be just what the theory would say. So, is that more than enough answer?
Yes, thank you. This is awesome. And let's say evolutionists believe in dynamo theory mostly, but what are main arguments against that theory?
Well, the main one is that it hasn't worked after about 100 years of trying to make it work. They started back in 1912, and the first version of their theory was pretty vague, and then the first hardcore case of their theory didn't work at all, and they kept making the theory more and more complicated because the earlier versions wouldn't work. So now they're at a stage where they have a lot of different versions of the dynamo theory, but none of them work. They don't really make any predictions numerically. They can't be that specific. And then computer simulations to try to make it work by computer simulation. Those have not worked. They don't get a field that looks like the Earth's field, and they have to make some not good assumptions anyhow, and so they don't work. And then this book here I'm talking about, Earth's Mysterious Magnetism, talks about an experiment that was done called the 3-meter experiment at the University of Maryland. That was a 3-meter metal sphere that contained molten sodium at about 100 degrees Fahrenheit, and it could spin very fast. They could spin at about 4 times a second, very rapid, big, huge, so tons of molten sodium. And they were hoping to get a dynamo to start up, but it never did. They just were not able to make the dynamo theory work experimentally. So I guess that's the problem. And then when they tried to use sort of guesses from the dynamo theory about what the magnetic fields of distant planets would be before they visited them, those didn't work either. And some of the planets and objects out there are really hard for them to understand, like the moon. The moon rotates very slowly. It only rotates once per month, and it has a tiny molten iron core. They can determine that from seismic waves in the moon, and but it's too small. It's only about 300 kilometers in radius, and they know the dynamo theory can't work by itself. But this is probably getting close to some other questions you had. The Apollo astronauts brought back rocks from the moon, and they were the older the rocks were, the more strongly they were magnetized, and the magnetic field of the moon back when it started was about the same strength as the Earth is now. But the core is so small that even according to my theory, the magnetic field should decay very rapidly with a half-life of about 100 years. And so now, 6,000 years later, it's got no field at all. So, but the dynamo theorists are in a big problem because they have this strong field that the rocks are telling them about, and they don't know how it could have started. Their theory wouldn't generate the field. So I guess that's an example of how the dynamo theory doesn't work.
Thank you. Good answer. Okay. Why God did even create Earth's magnetic field? Is there any purpose? And is it possible to live without that magnetic field?
Yes, it is possible to live without it. In fact, most living things wouldn't miss the field at all. There are some bacteria and some birds and some other creatures that use the Earth's magnetic field to navigate, to know which way is north as they migrate, for example. So those would have problems with no magnetic field, but they wouldn't die. But we wouldn't miss it at all. What should I say here? If the Earth's magnetic field died away after millions and millions of years, the wind of particles from the sun, the solar wind, would sweep the atmosphere of the Earth away. But if you don't think the Earth is that old, and I don't think it's nearly that old, there's no field required. And the particles from the sun and other cosmic rays would just zoom in, and we would get a little bit more particles at the equator. But right now, what happens is all those particles get scooped up by the magnetic field. And you see this picture of the aurora in my picture here of the book?
Yeah, I see.
That is particles that have been swept from the Earth's equator out in space down to the Earth's poles. And those are electrons and protons zooming downward and illuminating the Earth's atmosphere as they do. But there isn't so much radiation from that that people experience on the ground. The atmosphere absorbs most of that. So the people who live in polar latitudes, the Eskimos, we used to call them, now there's some more politically acceptable name for them, but the natives of that region don't have any problem with cosmic rays. So if you took away the magnetic field, they would probably get less cosmic rays than we have now. So if there were no magnetic field. So we don't need the magnetic field to exist or to live even comfortably. But I think God put the magnetic field there as a clue as to how he made the planets and how long ago he made them. It's sort of like a fingerprint or a signature. So that's the reason I think he made the magnetic fields. There probably are a few other good reasons, but I can't think of any. So.
Beautiful, thank you. Okay, did Earth experience magnetic reversals? If yes, how many and how much it takes for one reversal?
Well, we have evidence that the reversals during the Genesis flood happened about once every 3 days on the average. They were fast to begin with, and they slowed down toward the end. So it was something connected with the flood that generated the reversals, but they're recorded in the rocks on the continents and the rocks on the Earth's seafloor. And there were about 100 reversals in 1 year of the Genesis flood. So.
Okay, were there more in history later after flood, maybe?
There was one reversal after the flood, during the Ice Age after the flood, about 4,000 years ago. The time date that radioactive dating gives for that reversal would be about 700,000 years ago. But the radioactive dates have problems of their own. But the last reversal was during the Ice Age after the flood.
Okay, thank you. Now, does the data from measurements from 1835 to present fits better with exponential decay or with linear decay? What do you say?
It depends on which data you're talking about. If it's old data, I think you're looking at an article that's about 50 years old, or a book that was 50 years old by
it's a
Dr.
book from
Thomas Barnes.
Thomas Barnes, yeah.
Yeah. There's a lot more work. Let me show you another an article that I wrote in 2011. And this is from, let me move up to the article title. Earth's magnetic field is decaying steadily with a little rhythm. And this is all about a new compilation of data. But here, you see my arrow on the screen here?
Yes,
in this
yes.
figure 2. This is Barnes data plus a little bit more that I added later on in 1980s in the night, So this is pretty, the data have a lot of scatter, you see, around the line. And the origin of most of that scatter is not experimental error, but ways of analyzing the data. Each point represents a lot of measurements made over the whole Earth during the year 1830. And then they used a mathematical model to blend all that data together to get the strength of the basic part of the Earth's magnetic field, the dipole, they call it, or the dipole moment, and get a number for it. But each of these experimenters used a different mathematical model. And it turns out that most of that scatter from the line is due to using different mathematical models. So now there's a new compilation that's come out. Let me switch down to it. This is magnetic data from the International Geomagnetic Reference Field, called IGRF, for the years. What they did was they went back to the old data, took the raw data again, and plugged it into their mathematical model for all the years from 1900 to 2010. So here's a table with all of those data in it, and you plot those data, and you get very tiny dots. They're not scattered. The error bars around the dots were actually about the size of the dots themselves. So they got this very accurately. And this line here is an exponential fit, constant decay per year, a fit to that data, the best fit according to the computer. But you notice there's a little swing there, a little rhythm, a little sinusoid.
Yes, yes.
So
Why?
it looks like something else was affecting this, and I think I understand what it is. But it was adding a sinusoid. So I did a fit with a sinusoidal, and you can adjust the parameters of the sinusoid and the exponential, and so now the curved line is the fit of the two types of decay. So you get a very good fit, actually.
Wow.
So that's a long answer to a short question, but this new compilation is very exciting, and I haven't seen much in the secular world about either this fit or the sinusoid. The secular world seems to be silent about that. They're mystified by it. But my article talks about a possible cause of the sinusoid.
Great.
But anyhow, yeah.
So even if it is linear decay, can you say does that fit with old Earth or maybe younger Earth? What do you say?
Well, neither a linear fit nor an exponential fit would fit with an old Earth because they're too fast, way too fast. But the data itself, even though they're very good, can't distinguish over just a 100-year period, from 1900 to the year 2010. That's not enough to distinguish. And so a linear fit or an exponential fit gives about the same answer. And I discussed that, the two fits in this article. So maybe I should mention for your audience just how to get to this article. You go to the Creation Research Society website. That's creationresearch.org. And then on the main page, there's a tab on near the upper left that says Publications. And you hit that tab. And then there's the different publications of the Society. And the top name listed is the Creation Research Society Quarterly. So you click that, and then you go to the archive and go to, it's broken up by decades. So you go to the decade from 2010 to 2010, and go to this article, which is in 2011. I think it's the second issue. I'm not sure where I put that information, but that year, anyhow, 2011 has this article in it by me, and you can get really up-to-date information of the sort that you're asking about. So what you were seeing as a problem was mainly the noise from the different types of fits. You were asking about one spot of noise, let's see, in 1942, which was down here, and then another somewhere around here, maybe.
In 1945, there was increase. So is it?
Oh, yeah, right there.
Yeah.
There. And so
critics would say that it's now decaying, but sometimes it will come back, increase again. So what is your answer about that?
Well, if they had a theory that would justify what they say, I might listen to them. So, but they don't. So, I mean, they don't have a theory that can offer that kind of answer. I do have a theory about the cause of the reversals during the year of the Genesis flood, and that one just after, and it's in the International Conference on Creationism, their proceedings. So if you go to the website called International Conference on Creationism, pull up their proceedings archives, and I have an article in 1986 and another in 1990 on the reversals. And the one in 1990 offers a theory for how the reversals happened. But it was clearly something that happened during the flood caused the reversals. And then there's evidence of these rapid reversals that has been recorded. We have lava layers. Geoscientists have found lava layers that are so thin they had to cool down within a matter of a few days. And within those lava layers, they have found large pieces of a reversal. And they've done this for several layers at this one location in the state of Oregon called Steens Mountain. And it's recorded in both the creationist literature and in the secular literature. So they're very puzzled about how a reversal could happen that fast. But I'm not. I think I know how that happened. So.
Okay, great. So can you tell us something about losing energy of magnetic field? Because one could say it can recover. So is it true?
Yes. It's basically running down now. And it was losing energy even during the period of the reversals during the year of the Genesis flood, and it was losing energy pretty fast. But now it's just losing energy, and there's nothing bringing that energy back. It's so. What more can I say?
Okay, thank you. Nice. Let's move next. So, what is archaeomagnetism, and does that fit with biblical free decay theory?
Okay. Now, it does. Well, archaeomagnetism is the magnetism in artifacts like bricks or pottery that have been heated above a certain level called a Curie point. The Curie point is between 500 and 700 degrees centigrade. It's well below melting point, but it's pretty hot. It's hotter than your oven can get. So if a brick in a fireplace, for example, has been heated that hot, then when it last cooled down, it records the magnetic field that was going through it at that time and that place. So it records the direction and the strength of the magnetic field. So archaeomagnetism is when you use that magnetized bricks or magnetized pottery or magnetized other things that have been made by humans that you can put a good date on and to find out what the Earth's magnetic field did. Now, what do you mean by the creationist theory? There are several. What you can say from Barnes's theory is that the archaeomagnetic data back to about 1,000 years ago support his theory. But if you go back further than that, what you can say from the archaeomagnetic data that's earlier than that is that the Earth field, as you started curving over, as you went back to the time of Christ, and about the time of Christ, it was a maximum. It was about 30–40% higher than today's field. And then as you go back further, it goes back down in time. And then yet further, it bounces up and down until you get about to the time of the flood. And to get the correct dates on this, you have to correct the radiocarbon dates that are attached to those data. And I do this in that 1984 article in the International Conference on Creationism. So I discussed all that. So it looks like the reversals during the Genesis flood disturbed the field and sort of chopped the electric current up into different loops of different sizes and different orientations. And the smaller a loop, the faster it will decay. And so as these loops decayed away, it finally settled down to one moderate-sized loop that existed until about 1,000 years ago, and then it too decayed away. And now it's just one big loop of current, like the one I showed in my picture, and it's fading away. So I think I understand, and I think creationists understand that the field itself, the intensity of the field, bounced up and down after the flood, and then gradually settled down to an exponential decay. So we think we understand all that. So the other side just doesn't have any way to deal with that. So I forget what the original question was.
Yeah. Generally about archaeomagnetism, and does it fit with biblical
Okay.
theory? Yeah.
So yes, it fits. See, Barnes was a good analysis. I liked what he did, but he assumed that the core of the Earth was solid, or rather that being liquid, it didn't matter. So he didn't account for the perturbations that could occur to a core under certain circumstances, roiling and boiling, convection flows of fluid in the core would disturb the magnetic field. So a more detailed version of his theory that I put out accounts for these fluid motions in the core. So with the more detailed theory explains the data. So.
Nice. Does archaeomagnetism fits good with your calculation about 1,400 years decay?
Yes, it does. It does fit that. Now there are other components of the field, and the book I showed, the book I showed discusses all these things we were talking about, by the way, and gives the references for the technical articles. So that will help you and maybe the audience understand these things better than just my babbling away about it here. let's see, where was I going with that? Oh, there's other pieces of the Earth's magnetic field besides the main one. The main one is called the dipole or two-pole part of the field, and that's most of the field. But there are other parts of the field that have multiple poles, like imagine two bar magnets crossed. The field that they would produce is called a quadrupole field. And some of the Earth's field comes from a quadrupole. It doesn't really come from two bar magnets at the core. It comes from different loops of current, small loops of current. So if you account for the energy, uh, if you account for the energy in all those parts, it's all decreasing, and it's decreasing at a sensible rate right now. So
Yeah,
I don't
great.
know.
I read your article about IGRF data that shows in 30 years Earth magnetic field loses energy because a dipole part lose I believe 200 billion megajoules of
Oh
energy, and
yes,
non-dipole part gained only about 129 billion megajoules. So
yes.
is that
What
problem?
is hap what is happening in the field is complicated. Uh, it looks like these slow currents that are still going on after the flood are chopping up the main current into smaller pieces. So they're taking energy from the dipole and putting it into the quadrupole. But that can only go on so long, and then the quadrupole will also decay. So, but if you take account of all of these pieces, the overall energy is still decaying, but it's not decaying as fast as the dipole decays. So I believe that's my was that a 2001 article in
I believe 2010. I don't know. Maybe not.
2000? Oh, well, let's
Yeah,
see.
it's from ResearchGate. So.
So let's see. This is
Mhm,
this one that I'm showing is 2011,
mhm.
but the one that looks at all the energy and the different components of the field, I thought that was about 2001.
Oh, yeah,
Maybe
maybe.
I'm wrong.
Yeah.
So anyhow, that's in the quarterly, and you can go to creationresearch.org and find archived articles of that article and this one, and uh, more data and more stuff than you maybe could stand. So
Yeah, you published so much work. So this is your another book about some other topic, Starlight
yeah,
and Time. So I
yeah,
recommend to listeners to buy that.
yeah.
It's great. But
Well, by the
yeah.
way, that book is okay, and but that was my first stab at a cosmology, and I am now on stab number three. I'm on my third cosmology. So there were various deficiencies with the first two, but I've kept parts of those cosmologies and used them. But the cosmology I'm on now is more biblical cosmology. It uses more clues from scripture than the other two did.
Oh, nice. Okay,
So
it's science, so it changed. So it's natural.
yeah,
So, a quick question. Your conclusion from this article, over the 30-year period, net loss of energy was from all observable parts of the field about 1.5% of energy.
yeah,
So, does
right.
that fit with 1400 decay?
Yes, I think it does. I think in that article I gave the 1400 years. Um, now, let's see. That's a good question. I'm getting confused myself. Let's see. The time constant of the exponential part of the dipole is 1611 years, give or take 10 years. But that's just a dipole, and the energy decays slower than that.
Mhm.
So I think the 1400 years is the half-life of the energy decay, but I could be mistaken about that. Um,
Okay.
I get confused as to whether it's uh, whether it's an exponential time constant or a half-life, and whether it's energy or intensity.
Yeah, that's similar. So yeah. Okay.
In the dipole part, the energy decays twice as fast as the intensity, because the energy goes as the square of the intensity. So,
Yes. Okay. Nice. So next question is about paleomagnetism. And is it accurate? And can we, as a creationist, use paleomagnetic data with a young Earth creation perspective of accelerated radioactive decay, or is it totally useless? What do you say?
uh, I think magnetic data are good. They're accurate. I took a course in a graduate level course in paleomagnetism while I lived down in New Mexico. I didn't tell the teacher, the professor, that I was a creationist, and he liked me, but he was an evolutionist. But he was one of the world's experts on paleomagnetism, and I wanted to find out from inside whether or not it was reliable. And my answer is that yes, it's good. So now paleomagnetism is just like archaeomagnetism, except that it's applied to rocks instead of artifacts. So we have lots and lots of paleomagnetic information from the rocks, the rock layers on the continents, and the magnetic stripes on the ocean floor. We have lots of that data, and it's good. Uh, but don't attach the dates to each reversal that the evolutionists do, because they're relying on radioisotopes decay. And there's a project. Have you heard of the radioisotopes in the Age
Yeah,
of Days
rate
project?
project. Yeah, yeah.
Yeah.
Nice.
Well, we got about 4 lines of evidence that indicate that God greatly speeded up the rate of radioactive decay during the year of the Genesis flood, and He did it to accomplish certain geological things that had to happen during the flood. Um, but because of that accelerated rate, uh, if you don't take account of that, or if you do take account of that, you compress all the millions of years down to months during the Genesis flood. So, but you need to correct your radioactivity time scale to properly understand what the reversals were doing. So.
Oh, nice. Okay. So, one question about radiometric dating, C14. How Earth magnetic field affects on C14?
Oh, C14. That's a good question. Well, people used to think it did a lot, and Dr. Barnes thought so. But really, the particles that generate the neutrons in the Earth's atmosphere, the particles, the cosmic rays, are pretty strong in energy. They're about 1 GeV, giga electron volt, on that order. And at that energy, they are not much deflected by the Earth's magnetic field. So, but the lower energy particles would be affected. So there would be some effect on the rate of generation of carbon-14 in the Earth's atmosphere by these neutrons that are made by the high energy cosmic rays. There would be some effect of the Earth's magnetic field, but it wouldn't be a huge effect. And we need a huge effect to explain the data that we have. It looks like right after the flood, the ratio of carbon-14 to regular carbon was about 0.5% of what it is today. And it rose rapidly during the Ice Age for about 1,000 years till the time of Moses, about 1500 BC. And at his time, it was at about 90% of the ratio that we have today. So the ratio changed rapidly. And I think that's an effect of the acceleration of nuclear processes in the sun's core. At the same time, accelerated nuclear decay was going on elsewhere in the solar system. And I have an article tracing that effect in the International Conference on Creationism, and it's their latest meeting last summer. And I have an article. Let's see, when was it? When was it? Yeah, I think it was last summer. So anyhow, I have an article in their latest proceedings, if you look it up online. So
Was it a conference on creation?
yes,
Yeah,
yeah.
I watched it on Eric Hovind, I believe, live stream or something.
Oh,
Yeah,
oh,
it was a big meeting. Nice. Yeah.
it was in, well, anyhow, you can find it online, International Conference on Creationism, and it's their latest issue of their proceedings. The conferences happen about once every 5 years, and so it's the latest one.
Okay.
So anyhow, that's a long story again about carbon-14. But I don't think the Earth's magnetic field had as much effect as other people have assumed. Uh, but there was something that had a big effect on it, and I discuss that in the article. So,
Thank you. Okay, and this is a last question, but it is big. So we will talk about your predictions because they come true. And critics would say that they are not really predictions. You predicted that the moon once had a magnetic field, but is it true that Apollo 15 or 16 was aware that the moon had a magnetic field in the past?
the Apollo astronauts and the Apollo project at that time, I think it was, let me see what time that was. That was in 1971 and 1972. Yeah, June 1971, April 1972. That's when they collected some more rocks, but they didn't analyze all these rocks until the early 80s, in 1980. And so they didn't know that the moon's magnetic field had been that strong until sometime in the 80s. So, but I never claimed that as a prediction anyhow. I I think my first 1984 article on it already had data about the moon's former magnetic field. So that wasn't one of the predictions. I had other predictions about the solar system.
Okay, what about Venus? Can you say something about that?
Oh, well, Venus looks like it just doesn't have a very conductive core, so it doesn't have much of a magnetic field either. It would have been wiped out a long time ago. So Venus doesn't have much magnetic field. So
So did you
Mercury,
predict that, or is it later revealed?
well, it was already known by the time I wrote my 1984 article. So
Okay. What about Mercury?
Mercury was not known. Well, let's see, yes and no. I think Mercury's the first space probe that visited Mercury. I forget when that was. Maybe it was in the 70s. Uh, uh, it found they had been predicting by the dynamo theory that Mercury would have zero field, and instead it had about 1% of today's field. So they were, not real happy about that. But using that data that they had then, I could say I knew what my theory said the original field had been. Uh, Mercury's field, and it was pretty fast. And I predicted how fast that decay would be that a second probe might find. And the second probe did find about that amount of decay. After 30 or 36 years after the first probe, I think this was around 2011 or so, 2012. And then the other thing the theory predicted was that there would have been strong evidence of strong fields when Mercury began its existence. And so a space probe found near the North Pole of Mercury some very strongly magnetized lava flows. And they pointed to a much stronger field in the past. And that was a surprise to them because they thought, well, so they were amazed that Mercury could even get 1% of today's Earth's field, but they didn't think it would ever have been capable of getting much stronger fields. So my theory, though, had predicted that there would be this evidence of stronger fields. And on Mars, there was evidence of a much stronger field in the past, too. They found that. And that was something they didn't know. And both Mercury's field, by the way, its present field is opposite to that strong field in the past that was recorded in its lava flows. So there is at least one reversal of Mercury's magnetic field. And on Mars, it looks like it had a series of reversals and normals, at least 5 or 6 of them, from some stripes magnetic stripes found at the South Pole of Mars. So anyhow, magnetic fields have been doing interesting things in the past, and I think they have come as a big shock to the establishment. So
interesting. Okay, you wrote an article about Genesis flood that it affect even on a solar system, not only Earth. So you described that Mars was experiencing some catastrophic event. Is it true?
I don't believe I've written that article. Are you sure that was me? I have referred to it. Other people have thought that. Maybe I mentioned it in passing, that possibly the water on Mars and the craters on Mars might have been made by chunks of ice.
Yeah, craters. Yeah.
So you know, there would have been an atmosphere of water vapor, if so, that would allow liquid water to flow for a short time. And I suggested that might happen during the flood. But there are other possible explanations, and so creationists are discussing that right now. So,
great. Can you tell us what are the questions that creation puzzle with these topics and about magnetic field? Are there hard questions for you, maybe, or others?
No, the magnetic field seems to be a settled question with most people, so they don't have a problem, and I'm glad of that. But there's lots of others. So just recently, some creationist, Mike Ord and myself, for example, on the Creation Research Society, has a net, CRS net, and we and some other creationists were discussing those. And Mike Ord had an article about the possible causes of the water flows on Mars. And next in that series of articles, we'll consider whether or not it was chunks of ice that made the water flows. So,
great.
So we're still studying all that.
Great. He was here, our guest also, so he is a great scientist. Yeah. So what about Sun? You said that Sun experienced about 500 reversals.
Well, the sun's field right now reverses itself every 11 years. So it goes through a full cycle every 22 years. but they can measure the magnetic field in the gases at the sun's surface spectroscopically. They have a spectroscopic way to tell. So they know that the magnetic field of the sun reverses itself in conjunction with the number of sunspots that appear. So if you just take today's rate of reversals and extrapolate back 6,000 years, I guess that was about 500 reversals. Would be about, once every 11 years, divided into 6,000, would give you about 500. So, yeah.
So about the sun, if sun was old about 4 billion years, would that decay totally, or what do you say?
Oh, well, the rate of decay of most of these objects goes as the the exponential decay rate. That's that goes proportional to the radius of the object squared times its conductivity and another constant. So the sun is big enough that its magnetic field, even if it weren't generating its own, would still be there after many billions of years. So it's only the smaller objects like the moon and the Earth and Mars and Mercury and uh, the moons of Jupiter and a few others, the smaller objects lose their magnetic field quickly. But the bigger objects like Jupiter and Saturn and the Sun have a much slower decay time.
Okay.
So I hope that answered your question.
Yes, thank you. So now, what about Jupiter? Because it has a biggest magnetic field within our solar system.
Yes.
Yeah.
Yeah.
So, are there any predictions or?
In my theory, um, I pointed out that Jupiter was close to the maximum value for its magnetic field that my theory could explain. So its field hasn't decayed much since creation, apparently. Hasn't lost much energy. So, but that's because it is such a big object, and it has such a big conducting part of its interior. So, uh, so yes, if Jupiter had been a few percent stronger, it would have broken my theory. Yeah. So,
Okay, many critics would argue that you change a constant k and you adapt that so much. So, what is your answer on that?
well, I had this uh, constant, which I had a quantum mechanical rationale, and it was called K, and I had a rationale that it would be 1/4. But I decided I was full of baloney on that, and I said, let's go ahead and go with a K value of 1, which would be essentially it doesn't matter, and work on things like that. So, uh, yeah, I'm not perfect. I make
Yeah.
mistakes, and I decided I didn't need K. So
Okay, does k makes big changes, or is it?
no, it didn't make much change at all to anything. So,
Mhm.
but Jupiter was so big that K couldn't be 1/4. So K would have to equal 1/2 for that. So,
What about Earth? What is the value of k on that?
well, all of the values I'm using for K now are 1.
Oh,
I'm not
yeah,
using 1/4 anymore.
yeah.
So
Okay, okay, fair. So next, what about Saturn?
Saturn is about the same. It's a little bit less smaller field than Jupiter, but then it's a smaller planet than Jupiter, but it's up there, pretty large field. Uh,
Mhm.
and it has nearly its dipole is just about equally, perfectly aligned with its spin axis. I believe that surprised some people. The dynamo theorist would require it to be tilted. But my theory didn't care much whether it was aligned or not.
All right. And the last one is about Neptune and Uranus. Yeah.
Yeah.
So critics would say that you just luckily guess because it is between Jupiter and, let's say, Mercury, and you set some values that are not so unpredictable. So what do you say?
Well, there's a certain amount of slop in the predictions because before a space probe had visited those planets, nobody knew the size of their cores. And you have to have the size of the core to know how fast it decayed. So I could only make a range of predictions, and so I said that Jupiter's and Uranus's field would be on the close order of this value, and it turned out that the space probes actually came pretty close to both values. But there was a certain amount of error bars around my prediction, factor of 3, smaller or greater, just because I didn't know the size of their cores and how conductive they were.
Yeah, so they would say, critics, that it's not so impressive. So is it impressive for that year when you predicted?
It was impressive for Uranus, certainly. The dynamo theorists were predicting a field that was about 100,000 times lower than it had turned out to have, whereas my theory was, very close, certainly much better than 100,000. Yeah.
Okay. That's all of questions. Can you just say some conclusion? What electromagnetic fields say about God, and have your final message for audience?
I guess my theory for the planet's magnetic fields depends on a short time scale, 6 to 10,000 years, and it depends on the exact material being water, the original material being water, and we learned that from Scripture. We never would have expected that. So I would say that the magnetic fields of the solar system are very strongly support a straightforward view of Scripture, that God meant what he said when he was making it water, and he meant what he said when he gave the ages as being young, and so I think that's the bottom line you could get from the magnetic fields, is that Scripture turns out to be reliable, and if you can rely on it in scientific matters, you can rely on it in every other matter too. So
Yeah, we can rely on gospel and Jesus Christ also. So
right.
yeah, great point.
What we're relying on is that God gave his word, and God is reliable and true, and Jesus Christ is the truth. So we're saying, so the magnetic fields support all that. So.
Great. Dr. Russ, thank you for your time, and thanks for all these explanations. They are maybe a little hard for audience, but yeah, it's a blessing, and thank you for your work and all you do, and God bless you in everything.
Thank you. Thank you for the privilege, and
Thank you.
God bless you too.
God bless.